Good morning, dear students. Yes, so in the previous class, we were discussing uh, about nomenclature, right? So we were discussing the nomenclature of coordination compounds. So we have seen the rules. Okay, we have seen the rules. Then we have discussed the some of the examples. Okay, how to give the names for the anionic complexes. So we have seen some 13 complexes. Okay. So today we are going to see the rest part. So let us discuss the uh, complexes, how to give the names for the cationic complexes. Okay. So let us start. Okay. So let us start how to give the name for the cationic complexes. Okay. So here, so give the names of cationic complexes. Cationic complexes means what? You'll have a negative charge. Okay. Sorry, you'll have a positive charge on the complex. You'll have the positive charge on the complex. Now let us see. CuNH3 4SO4. Okay. Now if you remove this SO4, okay, so we are having a SO4 this, right? So how do we give the name for this complex? Cationic complex. So we know that the order should be, you should write first the cationic, okay, what is there inside the this. So it will have, now SO4 sulfate will have what charge? Sulfate will have -2 charge, right? And so this is the our cationic complex. So this we should name first. So if I see the previous example, if I take K3FeCN6, right? So our positive, this was what? Our positive cation was your potassium. So we wrote first potassium, right? We wrote first potassium and our negative was this, right? So then we write potassium hexacyanidopherrate 3, like that name, right? The order is what? First you have to write the name of the cation, then followed by the anion. Now here, which is a cation? This is your anion. So cation is this one. Okay, the complex is the cation. This complex is the cation. So first write the name of the cation and then tell me the anion. Yes, how do you write it? Try. I'll give you the first one. Okay, then you can try the others. Fine. So now here, the name of the complex is what? How many amine groups are there? 4. So the name is tetraamine, tetraamine. Then what you have? Tetraamine. Then we have copper. Copper. Let us find the this. So 0 equals to -2. So x is equals to +2. So the charge is 2 and outside the, this is, okay, so we complete the cation part. Now we'll write the negative part, anion. So that is sulfate. Okay, that is what? Sulfate. Okay, fine. Let us go for the next one. Platinum. I hope it is clear now. Okay, how to give the names. So now you can try this. Yes. Okay, each member try. Yes. Second one, third one, fourth one. Who wants to try second one? Yes. Hexamino platinum chloride. Okay. Let us see. So hexaamine, six amines are there. So hexaamine, then platinum. Okay. So let us find the oxidation state. Uh, okay, oxidation state. So platinum is X plus ammonia is a neutral molecule, so it will be zero. It will be zero. Ammonia is a neutral molecule, so it is zero. Then what you have equals to minus 4. So X is equals to plus. So platinum charge is plus 4. And then what you have to write? Chloride. Outside this is your negative charge, that is chloride. Okay. So this is the naming. This is the naming. Hexamine, platinum, two, not two. See here, four chlorines are there, right? Four chlorines. So ammonia is a neutral molecule. So the charge will be zero. Outside the sphere, what you have? Cl4. So if you remove, so platinum is X. So ammonia is zero because 6 into 0 will be 0 equals to each chlorine is minus 1. So how many chlorines you have? 4 chlorines. So it will be minus 4. Okay, so X will be plus 4. Fine. Next one, try second one. Yes, try next one. Diamino silver. No, we don't use. Okay. Diamino, diamine. Okay. Diamine. Then silver. Diamine silver. What is the oxidation state of silver? Yes, silver will keep it as X plus amine is 0 equals to minus 1. So X is equals to plus 1. Okay. So diamine silver 1 chloride. Okay. So the name is diamine silver 1 chloride. Okay. Next one. Fourth one. Fourth one. Yes. Fourth one. So there are now, two different ligands. What is the amino group? Another is the aqua group. So which will come first, amine or aqua? AMMINE or AQCA? Your amine group will come first, right? So how many amine groups are there? So AMM will come first, then will your aqua come first. Okay. So how you will write the name? So how many amine group? Tri. So triamine, okay, triamine, triaqua, okay, chromium 3 chloride. Yes, very good. Baby has answered. Very good. So it is triamine, triaqua. Okay. Then, so let us see the charge of chromium. Chromium. So chromium is X plus this is 0 and this is 0. Water is also a neutral molecule equals to -3. So S is equals to +3. So chromium is 3 and then chloride. Okay. Only whenever so we know that whenever you have a cationic complex, okay, so for cationic complex, your metal will end with the same name, okay, that is chromium. But whenever you have anionic complexes, what is the difference? Yes, what is the difference? Whenever you have an anionic complex, your central metal atom will end with ATE, chromate, okay, platinate, then cuprate. So, like this, cobaltate, like that, whenever you have a anionic complex. But when you have a cationic complex, what will happen? It will end with the same specific name. Okay. So this is clear. So we have seen one, two, three, four, four. Yeah, four. Okay. So let me clear this. So it is triamine, triaqua, okay, chromium, 3 chloride. Okay. Chromium 3 chloride. Fine. Let us go for the next one. Okay. So fifth one, try fifth one. What is the fifth one? Okay, diamine, chlorido, nitrito, platinum 2. Okay, Yamuna has answered. Diamine, chlorido, nitrito, platinum 2. Diamine, chlorido, nitrito, platinum 2. Very good. Yes, it is correct. Okay, so it is diamine. Okay, then you have a chlorido group, chlorido. Then you have what? Nitrato, nitrito. Then what you have? Platinum, platinum. And what is a charge? What is a charge? So platinum is X, platinum is X, plus ammonia is 0, plus chlorine is -1, and NO3 is NO3 -1. NO3 is also -1 equals to 0. So X is equals to -2 equals to 0. So X is equals to +2. Okay. So the charge on this is platinum 2. Very good. Okay, it is platinum 2. Fine. So let us go for the next one. So cobalt, Cl2, En twice, Cl. Okay, tell this. Yes. What is the name? So this is a ethylene diamine, right? Ethylene diamine group. Now, ethylene diamine and your chlorido. Which comes first? Your chlorido. So how many chlorido atoms are there? Two. So it is what? Dichlorido. Then now this is also, so we are going to use what? Bis. So bis, ethylene diamine, ethylene diamine. Okay. Dichlorido, bis, ethylene diamine. Then your cobalt. What is the charge? Let us see. X minus 2. Ethylene diamine is 0, I guess. Then equals to minus 1. So X is equals to minus 1. Ethylene diamine is equals to minus 1. Minus 1. This becomes plus 2. So this becomes plus 1. No, it should come 3. Ethylene diamine, what is the charge? Dichlorido, bis diethylenamide, cobalt 3 chloride. Yes. But how we are getting cobalt 3? Ethylene diamine is 0. This is minus 2. Okay. So cobalt is X, then plus chlorines are minus 2. Chlorines are minus 2. Ethylene diamine is 0 equals to minus 1. The charge. X is equals to X minus 2 equals to minus 1. So X is equals to minus 1 plus 2. So it is coming plus 1. But it should come plus 3. It should come plus 3. Okay, I'll see this. I'll see this. Okay, so it is cobalt 3 and then chloride. Okay, next one. Next one. Yes, try next one. So here we have cobalt as well as carbonate. So we have amine and we have carbonate. So which will come first? Amine. So it is pentaamine, then car carbonate or carbonato. Okay, carbonato. Then cobalt. Let us see the charge. X plus 0 minus 2 equals to minus 1. So X is equals to minus 2 minus 1. X is equals to minus 1. Again the same. Cobalt is minus 2. CO3 minus 2 and this is minus 1. So minus 2 is equals to minus 1. Mm, The name is here pentamine cobalt 3. Okay, and chloride. Cobalt 3 chloride. Here, Hmm. Fine. So let us go for the next one. We'll go for the next one. CO, NH3, 5, Cl, Cl2. Then CO, En twice, F2, ClO4. Then PT, NH3 twice, Cl. Then NH2, CH3 and Cl. Next is CO, En3 twice, SO4 thrice. Okay, we'll solve this much only. Tell the names, this particular compound. So there are chlorido and amino group. So first will be your amino. So how many? Penta. So pentaamine, pentaamine, then chlorido, chlorido. Then what you have? Cobalt, cobalt. What is the charge? X plus 0, minus 1, minus 1, is 2, minus 2. So this will going to become minus 3. So it becomes 3 chloride. Okay, next one. This one. So you have a ethylene diamine and fluoro group. Okay. So ethylene diamine, E will comes first, then F will come. So what will write? Bis ethylene diamine, bis ethylene diamine, difluoride, difluoride. Then we have cobalt 3, and this is chlorate, perchlorate. Okay, it is perchlorate. Okay. Next one, we have amino, chlorido, then we have what? Methyl, methylamine we have. Yes, so which will come first? So this is M, methylamine. This is chlorido. This will have, so your name will be diamine, diamine. Then we have chlorido, chlorido. Then we have what? Methylamine, methylamine. Then we have what? Platinum, platinum. The charge on the platinum is what? So X plus 0 minus 1 plus 0 equals to minus 1. So X will be 2. The charge will be 2. So platinum 2 chloride. Okay, platinum 2 chloride. So these are the names. Okay, so whenever you have a cationic complexes, so like this, you can give the names. Okay. So, is it clear? We have discussed about how to give the names for cationic and anionic complexes. Is it clear? Okay, fine. So let us go for the next set of example. So name of the complexes. So when you have name of the complexes containing, okay, when it is containing, that is cation and anion. So in the same complex, when you have cation and anion. So in this case, what you have to do, the name of the cation and anion is written without any gap. Suppose I have one example. Okay, I have one example that is Ag. I have Ag NH3 twice and AgCN twice minus 1. So now you are what you can see that both cation as well as anion is present. So this is a anion, okay, and this is a cation. So now what we are going to do? So your diamine silver is a cation. So how you are going to write? So I am going to write first this. Okay, first I'll write diamine, then silver, okay, and the charge is 1, and this is what? Dicyano. So dicyanido, dicyanido, arginate, okay, argentate, the charge is 1. So like this you are going to name. Second one more example, cobalt NH3 6, chromium CN6. Okay. Anybody? Anybody wants to try this? So cobalt amino and chromium hexa this. So which will be the, so this is your positive cation and this is your anion. Yes. So what will be the name? Hexaamine, 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 then cobalt 3 and hexacyanido, chromate 3. So like this, so whenever you have a complexes and are containing both cation as well as anion complexes, so first you have to write the name of the cation and anion in the continuous manner. Okay, is it clear up to here? Yes, is it clear? Is it clear, students? So now I'm going to give the names. Okay, so you have to write the formula. Next is what? I'll give the names. Okay, I'll give you the names. What you have to do? You have to write the formula. Okay, so let us see how we'll do that. So tetraamine, aqua, chlorido, cobalt 3, chloride. So how will you give this? How will you give the name? Then is potassium tetrahydroxido zincate 2. Then third one, potassium trioxalato aluminate 3. And last one, we'll take fourth one, dichlorido bis ethane 1,2 diamine cobalt 3. Okay, so how will you name this first one? First one. So what you have? Cobalt 3 chloride. So this is what? This is a negative anion complex. Okay, cobalt is written completely. So it is a anionic complex. So this is a anionic complex. So first we'll follow the rule. So let us take the, we'll maintain the bracket. Then what will come? So your cobalt will come, right? Then what is there? Tetraamine is there. Okay, cobalt, then your tetraamine, so NH3 4. Then you have aqua, then you have aqua, and then you have chlorido, and then you have chloride. Okay, then you have chloride. So what will be the charge? So cobalt is X. Okay, what will be the charge? Cobalt is okay, it is 3. Cobalt is 3. So let us find out the charge of how much chlorine should be taken. So cobalt is 3 plus 0 plus 0 minus 1 equals to X. Okay, so this will be how much? So this will be 2. So X is equals to 2. So Cl will be 2. So chlorides will be 2 here. Okay, next one. Next, find out next one. So here zincate is there, ATE. So this is a cationic complex. So this is what? This is a cationic complex. So the name of the metal is ending with AT. So it is a, so K3 will come, or so K will come outside. Then tetrahydroxido. Hydroxido means OH. Okay. So zincate means zinc and OH4. Now zincate is 2. So 2 and 2 plus minus 4. Okay, 2 plus minus 4. So it will be how much? It will be 2 minus 4 equals to 2. So K2. So it will be K2. Okay, fine. Next one. Potassium trioxaloaluminate. Again a cationic complex. Again a cationic complex. So what you have, potassium will be outside, trioxaloaluminate. So aluminium will be there, and oxalato is what? C2O4. Trioxalato means 3. Now again find out aluminum, what is the charge? They have given us 3. 3 and oxalato is C2O4 minus mm, minus 2. Okay, so this is minus 2 plus that is minus 2 into 3. So it is minus 6. So K3. So this becomes 3 minus 6 is equals to 3. So K3. So it becomes K3. Okay, it becomes K3. Last dichlorido, bis, ethane, cobalt. Right. So this is a anionic complex again. Anionic complex because it is cobalt. Fine. Write down now. So what will come? Cobalt will come. Then what you have? Dichlorido. Then you have ethylene diamine. So it will be En twice. So let us see the charge. Okay. So cobalt is 3. Then dichlorido is minus 2. Then ethylene diamine is 0. Then what you have? So it will be equals to 0. So x is equals 3 equals to 1. So it is a plus 1. So the charge will be 3 minus 2 is 1. 3 minus 2 is 1. So the charge is 1. Okay, the charge on the overall complex is 1. Okay. So we have seen 4. So let us see some more complexes. Okay. So fifth one, tetra carbonyl nickel 0. Okay. So this is fifth one. Then sixth one, tetra amine diaqua cobalt 3 chloride. Okay. Seventh one, potassium tetra cyanido nickelate 2. Eighth one, tris ethane 1,2 diamine chromium 3 chloride. Okay, try these now. Try this. So fifth one, so tetracarbonyl nickel. How will you write it? Tetracarbonyl, tetracarbonyl and nickel. So this is a complex. Next one, cobalt. Okay, so this is again a anionic complex. Anionic complex. So cobalt. Then you have tetraamine, NH3, 4, diaqua. So it is H2O twice, H2O twice, diaqua. And what you have? Chloride. So the charge will be cobalt is 3 plus 0 plus 0 mm, plus 0. So what will be the charge? Chloride. So how many chlorines will be there? So it will be equals to X. So X will be equals to 3. So 3 chlorine. So it will be Cl3. So this is outside the sphere, right? Because it is a anionic complex. Okay. Next one. Next one. A nickelate. So this is a cationic complex. This is a cationic complex. Sorry. So this is a anion. This is a cationic complex, cobalt, and this is anionic complex. Okay. This is a cationic complex. Whenever it ends with ATE, okay, then it is a anionic complex, right? And whenever it ends with the complete name, then it is what? It is a cationic complex. Okay, don't get confused. So then name of this. So potassium Okay, potassium will be outside the sphere. No, potassium. Yes. What is the name? Try. Try. So potassium will be outside the sphere. Then you have nickel and 4 cyanide group. Okay, so let us see how many potassium we have. So potassium will keep it as X, or we'll write it as nickel is how much? Nickel is 2 plus each cyanide is -1. So it is -4 equals to X. So it will be 2. So K2. Okay, K2. So X will be 2. Okay, next one, eighth one. Students, try eighth one. Chromium you have. So chromium. Then you have what? Chromium. So this is what? It is a cationic complex. So this is again a cationic complex. So chromium. Then tris, ethylene, ethane diamine. So it is En thrice. And then what you have? Chloride. Then you have chloride outside the sphere. So let us see what will be the charge. Chromium is 3. Ethane diamine is 0. So it will be X. So X will be equals to 3. So the chlorine number of atoms is 3. Okay. Is it clear up to here? Yes, is it clear? Don't get confused. Okay, so just remember the rules. Okay, so whenever you have a so how will you recall the things? So if it is ending with ATE, that means it is a your anionic complex. Okay, so like that you have to remember all the things. Fine. Now next one. So next set of examples. So amine, bromido, chlorido, nitrito, N platinate. 2. Next one, dichlorido, bis, ethane, 1, 2, diamine, platinum, 4, nitrate. Okay, next one, tetra, bromido, cuprate. 2. And last one, penta, amine, nitrito, O, cobalt, 3. Okay, find out now. Find out these names. So amino, bromido, chlorido, platinum. So platinate it is. So again, it is a what? It is a anionic complex. Platinate means it is a anionic complex. So what will there? Bracket. So platinum. So let us write bromine. Sorry, amine. Then I'll write bromine. Then I'll write chlorido. Okay, then I have nitrito. Nitrito is what? NO2. So nitrito. And what will be the charge? Let us see. So platinum is X. Sorry, platinum is given, no, 2. So platinum is 2 plus 0 -1 -1 and NO2 NO2 is -1. So again -1. Okay, so 2 -2 is 0. So the charge will be 1. So -1. So the charge is what? -1. The charge will be -1. So 2 -2 is 0 and it is -1. So the charge will be -1. Next one. Next one. Dichlorido bis ethane 1,2 di and platinum nitrate. Platinum. So this is a cationic complex. Cationic complex. So what all will come? So first will be your platinum. Then will be your chlorine. then ethylene diamine bis twice, then nitrate will be outside the sphere, NO3. So dichlorido, platinum is 4, -2, 0 equals to X. So it is 2. So the number of nitrates are 2. So again a cationic complex. Okay. So this is 2 is equals to X. Okay. Next one, tetrabromido cuprate. Cuprate means again this is a anionic complex. So copper, then bromido means 4. Br4. What will be the charge? Copper is 2, bromine is -4 equals to X. So X is equals to 2. So the charge is -2. Okay, so the charge on the complex is -2. So this is the name of the complex. Next one, last one. So cobalt means this is a your cationic complex. So cobalt, then how many amines? Penta. So 5 amines. Then what you have? Nitrito O. Nitrito O means ONO. Okay, nitrito O. Then let us see the charge. Cobalt is 3, amino is 0, nitrito is -1 equals to X. So X is equals to 2. So the charge is +2. Is it clear? Is it clear up to here? So this completes your IUPAC nomenclature. Okay, so I have tried to solve all the type. Okay, so we have discussed the rules also. So we have discussed the rules, then we have discussed how to write the cationic complex, anionic complex when you have both, and also how to write the formulas if you have like this. Okay, if you have the sentences in the form of sentences also, so you know how to write the names also, how to write the complexes also. Is it clear up to here, everybody? Yes, students, is it clear? Any doubts? So yes, fine. Okay, so what you have to do, you have to practice this. Okay, go through all the what you said, rules. Okay, all the IUPAC rules, and try to solve this every day. Then only it will go in your head. Okay, you will be very fast. Okay, you should means your time will not be wasted in thinking. So you try to solve this every day. Okay, it will be a practice for you. So tomorrow is Sunday. So you can do this. So please practice the IUPAC nomenclature. Okay. And on Monday, we are going to see the isomerism. Okay, isomerism. So isomerism is also a very important part in coordination compound. So that things we are going to discuss on Monday. Okay. Any doubts up to here? Yes. Fine. No doubts. Okay. So we'll be ending this session here. Okay. We'll meet on Monday. So please practice the isomerism. So on Monday, let us discuss the remaining things. Okay. So thank you. Have a good day. Have a great weekend.